Welcome back to another Marcus Maths video. Today we're going to be doing a lot more complex differentiation strategies. Expect to see a wide diversity of these strategies. We're going to be doing trigonometric functions, we're going to be doing inverse functions, we're going to be doing all sorts of things, inverse trigonometric functions as well. So lots of complex strategies we're going to be learning about, lots of stuff that we're going to have to actually memorize, like our inverse trigonometric function formulas, some different notations, and the such. Very, very important video. It's going to be a little bit longer. There's going to be in-depth explanations of each of these questions. Let's go ahead and get started. Make sure to like and subscribe to the YouTube channel if you haven't already, as we continue with our AP Calculus study. Okay, our first question, we're going to find the derivative of cosine squared of x over x. We have a simple quotient rule here, so we can take low times derivative of the high, which is a composite function, where we're going to use chain rule. If you didn't see last video, so chain rule, we're going to have 2 out the front, then we're going to have cosine of x to the power 1, so it's just cos of x, and then times derivative of the inside function. Derivative of cosine is negative sine of x. So now we're going to subtract top function, cosine squared of x, times derivative of the high function, which is, times derivative of the low function, which is just 1, over low function squared. Now, we have all of this, and we can factor out a cosine out of a negative cosine, in fact, out of each of these terms. Let's first simplify our first term here, because we can kind of split it up into this term in our numerator and then our negative cosine squared of x. So let's simplify that first parentheses. That first parentheses is going to simplify to negative 2x cosine of x sine of x. So if you notice, we can factor out a negative cosine of x out of both the first term and the second term. Even though they're not multiplying with each other, they're actually subtracting. That's why we can factor out of each of them, because we have our two distinct terms that are combining. All right, and now from here, what we're going to do, we're going to divide the first term here by negative cosine of x, and then the second term also by negative cosine of x. So that's going to be our greatest common factor, negative cosine of x. Inside of our parentheses, it's going to look like positive 2x sine of x. That is what we get when we divide that first term by negative cosine of x. And then the second term is just plus cosine of x. So inside the parentheses is 2x times sine of x plus cosine of x. Then this is all just divided by x squared. If you don't notice already, this matches perfectly with answer choice A. So we're just using quotient rule and a combination of our chain rule as well to solve this question. Okay, on to the next. This person's finding the derivative of the product of these. So derivative of the product, we're going to have to use product rule, but also notice, well, this is just simply going to be product rule. We're going to use x to the power 1/2 to differentiate here. So let's see if they make a mistake. Okay, find the derivatives of the factors. Well, this person should really be using product rule here. Let's see if they actually use it correctly. Okay, so they find the derivatives of both. This is the correct derivative of x to the power 9, and that is the correct derivative of the square root of x. So let's see. Well, they didn't use product rule. Product rule takes the derivative of the first function times regular of the second function plus derivative of the second function times regular of the first function. So, didn't state the correct product rule is the correct way to interpret this question. Okay, on to the next. Which sequence of rules can be used in order to differentiate f in its current form? First of all, we need to notice that we have two functions multiplying. We have x squared, and then we have tangent. But then tangent has an outside function, which is a tangent function, and also an inner function, which is a 2x to the power of 5. So we're going to have to start with product rule, and then while we're doing product rule, we're going to do chain rule when we differentiate that second function, that tangent one. So that is the correct way to do this. Moving on to question number 4, we're trying to find the derivative of inverse cosine of 2x. How these work is that we just need to know it off by heart, pretty much. Our formula for inverse cosine, so we can rewrite our cosine as cosine to the power of -1 of x, and how the derivative of this works, so d over dx of this function, it's going to be negative 1 over the square root of 1 minus x, well, or our argument, let's state this as u actually, of u to the power of 2. 1 minus u to the power of 2. And then we have to also utilize chain rule in case u is a function as well. Because, okay, we have the outside function times the derivative of the inside function as well. So we'll notate that by times du over dx. All right, so we can see that u is equal to 2x here. So u squared is 4x squared. And since this is indeed a function, we're going to have to multiply by the derivative, which is multiplied by 2. So we know our numerator is going to be negative 2. And then our denominator is going to be 4x squared. So there's whole theory on how we can find these inverse trigonometric functions in the first place. But I just recommend we memorize arc cosine, arc tangent, and arc sine, as these are the most commonly seen ones. And then when we get to integrals, we're also going to have to remember the integrals for these as well, or the anti-differentiations. Okay, so that matches answer choice A as the correct one here. Moving on to question number 5, we have some implicit differentiation. This is really fun stuff. If you don't know how these works, we need to separate our variables, get like y's on one side and x's on the other, and then we're going to differentiate the left side. When we differentiate a y, we're going to have to add on a dy over dx, and then we get the dy over dx by itself, and then when that's isolated, that is equal to the function. And then, well, if we have to do a second order differentiation, I'm pretty sure we'll learn about that later, but not in today's lesson. So first step is to simply get some variables by themselves as much as we can. So we can move over the 4x, which is at least encouraging. All right, so we're going to move over the 4x. So we have negative 4x plus 10. And then we have the rest of our function here. So we have negative x squared y plus y to the power of 3. So we're going to differentiate both sides. Our right side actually is very easy. It's just equal to negative 4. But our left side's a little bit more complex. We have the y here. So whenever we take the derivative of a y, it's going to read as dy over dx. So this is going to be 3y squared times dy over dx. So that is the derivative of the y here, because we are differentiating in relation to x. So that's the derivative of y to the power of 3. Now we're going to differentiate our product rule here. Remember product rule, we take the derivative of the first one, 2x, since it's the x, we don't have to include it. And then we have the regular y, and then we have plus the regular x, which is, well, minus x squared. And then times derivative of the y. The derivative of the y would usually be 1, but whenever we take derivative of the y, we have to have dy over dx. So the product rule here gets us negative 2xy minus x squared dy over dx. And then we have plus our 3y squared dy over dx equals negative 4. Now we're going to isolate the dy over dx. We can move over the negative 2xy. So now we're going to have negative 4 plus 2xy in our numerator, while we're going to be left with negative x squared dy over dx and 3y squared dy over dx. We're going to factor dy over dx out of each of the terms. So we are simply left with, inside the parentheses, negative x squared plus 3y squared. And then we're going to just divide both sides by this in the parentheses to get the dy over dx completely by itself. So now our dy over dx is equal to negative 4 plus 2xy over negative x squared plus 3y to the power of 2. All right, so we've isolated dy over dx. This is the implicit differentiation here. Now we're going to find the value at the point 1, 2. 1 is the x value, 2 is the y value. We're going to substitute into, and we're going to simplify. So let's solve our numerator first. Our numerator, we get negative 4 plus 2 times 1 times 2, so negative 4 plus 4 is 0. Doesn't matter what the denominator is going to be. The answer is going to be 0 regardless. Let's just double check. Yep. So the answer is 0 here. All right. Fantastic. On to the next here. F and h are inverse functions. We're trying to find the derivative of h. So let's pretend that h is the inverse function here. So here's a notation for inverse functions. We have the derivative of f of negative 1 of x is equal to 1 over the derivative of f, parentheses, the value of the inverse function at x. Okay, so the value of the inverse function at x, so we're going to start with the value of h of x at negative 4 is 1. So now we're going to do 1 over the value of the derivative of f at 1. So this is equal to 4. So our answer is simply 1 over 4. So as long as we know the notation, this stuff is pretty easy. Okay, on to our last question here, question number 7. How would you write g of x so it can be differentiated using the product rule? Product rule right here, it's a quotient. So we're going to have to rewrite this to get our x outside of the denominator. How we write it to get outside the denominator, we just how we move something from the denominator to the numerator, we can use negative exponents. If we move it up, it's going to cause our x to the power 1 to turn into x to the power of negative 1. So we're simply going to be left with the square root of x times x to the power of negative 1, or we can write it in any order that we'd like, property of multiplication. And this matches answer choice C, and this is applicable when x is not equal to 0, so then our function is not undefined. So C is the correct answer here. Alright, that is all for today. We went into some complex differentiation strategies. This stuff is definitely hard. So if you have any questions in the comments, please let me know and I will be sure to help you out there. Make sure to have a good rest of your day. Make sure to subscribe and like the video if you haven't already. And goodbye.